Okay, one more little calorimetry problem before we move into the two different interpretations of Hess's law. With this calorimetry problem, it's a little different. So it says that you've got 23.6 grams of calcium chloride and you dissolve it in water. Now, when you put calcium chloride in water, it's actually an exothermic process. When it becomes, when it goes into solution, it produces heat. So what happens is that the temperature rose of the water from 25 to 38.7. So the calcium chloride in water made the temperature of the water and the whole solution go up. Okay. Now, this is where it's a little different than the other calorimetry problem. It says that the heat capacity of the calorimeter and its contents. What does that mean? Heat capacity of the calorimeter and its contents means that the heat capacity of the calorimeter and the whole solution is. So that C value is going to be used instead of a specific heat and a C value. This basically incorporates the whole thing. So it's basically Q is equal to C delta T. That's it. I know they've given us the mass of the calcium chloride, and we're going to use that to figure out the final answer. What is the enthalpy change per mole? But right now, because they haven't given us specific heat, or they haven't, said how much water there is or anything like that, you just assume that, okay, because they're saying the heat capacity of the calorimeter and its contents, we don't have to do the ms delta T plus C delta T. You just do C delta T. Okay, so we've got this 1,258 joules per degree Celsius. And then our delta T would be 38.7 minus 25. So that would be, what is it, 12.3 degrees, I think. Yep. All right, so you do the math. Hopefully I'm doing the math correctly. Let me double check here. 38.7 minus 25 is equal to, oh, good thing I double checked. What did I just do? 38.7, oh my goodness. Sorry guys. I was doing weird math. Always better if you double check before you start taping a video, right? Yeah, that's okay. So 1,258 times 13.7 times 13.7. The degrees Celsius cancel, and I get 17234.6. Humongous number. And I am going to round it to, I guess, 366. So 172, and then 000. Okay, joules. Or you could put it inside. Here we go. Joules. 1, 2, 3. Yep. Or 17.2 kilojoules. Okay, so 17.2 kilojoules is what is being heat amount of produced based on this many grams of calcium chloride. But they want to know a mole of calcium chloride. So we need to convert our grams of calcium chloride to moles. And we're going to do this. We'll put it up here. So 17.2 kilojoules per, how much was it? It was 23.6 per 23.6 grams of calcium chloride. Well, we want it per moles, 1 mole of calcium chloride. So crunch the numbers. Calcium's 40, chlorine is 35.5. Okay, 111.1 grams of calcium chloride. So this way the grams will cancel, and you're going to end up with kilojoules per mole because they want it per mole of calcium chloride. So that's 17.2 divided by 23.6 times 111.1, and you get 80.97. If I want 3 sig figs, this would be 81. So 81.0 kilojoules. All right. Since they want a delta H, we have to put a sign. Remember, temperature goes up. It was exothermic, so we say delta H is equal to negative 81.0 kilojoules. So again, this is a type of calorimetry problem where they give you the heat capacity of the calorimeter and its contents. So it's a straightforward C delta T instead of MS delta T plus C delta T. Okay? All right, so we're done with calorimetry and we're moving on to Hess's law. I really, really like Hess's law. Always choose a whole bunch of Hess's law problems for the exam. So make sure you understand this super well, guys. All right, so 2 different interpretations of Hess's law. Let me write down the first one and give you sort of a definition for it. So Hess's, I don't know, I guess apostrophe S? I don't know, just too many S's here. Hess's law of summation. Okay. Okay, so for a chemical reaction that can be written, it's always better if I have this written up on the board already for you guys, that can be written as a sum of 2 or more equations, or some of more, 2 or more steps. The enthalpy change of the overall equation is the sum of the enthalpy changes of the individual steps, changes of the individual steps. I could have probably told you guys to just read it in the book, but anyway, this is the actual definition for the first interpretation of Hess's law. For a chemical reaction that can be written as a sum of 2 or more steps, the enthalpy change of the overall equation is the sum of the enthalpy changes of the individual steps. Okay, great. What does that actually mean, and how do we apply it? All right, I have a bunch of examples for this, and pay attention. All right, so our goal is to figure out the delta H of this reaction. 2 sulfur solid plus 3 oxygen gas will give you 2 sulfur trioxide gas. I want the delta H for this. Okay, let me check and see everything's balanced. Yep. 2 sulfur solid plus 2 moles of sulfur solid plus 3 moles of oxygen gas will give you 2 moles of sulfur trioxide. I want the delta H for this reaction. Okay, remember, what we just did with calorimetry, we figured out the delta H using calorimetry. Well, now we're going to use Hess's law instead of calorimetry. So I've got 2 equations that when I add them together correctly, they will end up being this one. And if I can do that and then add up the enthalpy change for those 2 equations, I will figure this one out. But the trick is to manipulate the equations so that when you add them, you end up with this. All right, so what are the 2 equations I've been given? S solid plus O2 gas will give you sulfur dioxide gas. And the delta H for this is, where is it? Negative 297. These are all in kilojoules, okay, for this one. And then the other equation I was given is 2 sulfur trioxide gas will decompose to form 2 sulfur dioxide gas plus oxygen gas. And the delta H for this one is positive 198 kilojoules. So this one's exothermic, this one's endothermic. Okay, so I was given these. I want to end up with this. I need to find a way to manipulate these guys so I end up with this. And this is the way I approach it. It's actually kind of fun and not difficult at all. So just pay attention. All right. You notice that you've got 2 sulfurs on this side and 3 oxygens on this side. Okay? And you have 2 sulfur trioxides over on this side. Okay. So I see this one over here. If I flip it, I end up with a sulfur trioxide on this side. So let's start with that. Let's just flip this one. And you guys remember what we talked about when we first started chapter 6. Anytime you manipulate a thermochemical equation, whatever you do to this, you have to do to the delta H. So if I'm flipping this, what do I do to this? I change the sign. So let's go ahead and flip this. I'm going to go 2 SO2 gas plus O2 gas will give you 2 SO3 gas. I'm going to flip this so it becomes minus 198. Okay, so these are how I'm manipulating the equations. Okay, so I manipulated this one enough. Now let me manipulate this one over here. I notice that I've got oxygen here and here, and I have SO2 here and here, but the S is all by itself here. So let me focus on just the sulfur right now. So I need 2 sulfurs. So let's go ahead and multiply this whole thing by 2. I'm going to do this because I know that everything else is going to work out. If I can manipulate one main thing, usually the rest of the equation works out beautifully. So I'm going to take everything in this equation and multiply it by 2. So it's going to be, and not flip it because I want the 2 sulfurs to be on this side. So I'm going to go 2 sulfur solid plus 2 oxygen, gas will give you 2 sulfur dioxide gas. And then what do? I have to multiply this by 2. So the negative 297 times 2 becomes negative 594. Okay. Now let's see what we can do. Remember, it's the law of summation. Hess's law of summation. It means we're going to add stuff together. So if I add these 2 equations, what do I have? I have 2 sulfur dioxides on the left, and I have 2 sulfur dioxides on the right. I can cancel them out. I have 1 oxygen and 2 oxygens. I add them together. They're on the same side. That's 3 oxygens. So at the end, I have 2 sulfur solids plus 3 oxygen gas will give you 2 sulfur trioxide gas. Look. It's exactly the same as what we were looking for here. The 2 sulfurs, 3 oxygens, and 2 sulfur trioxides. Excellent. So now we're allowed to take these 2 numbers, add them together, minus 198 plus minus 594. You end up with delta H for this is minus 792. Yep, minus 792 kilojoules. Okay, we did it. All right, that's Hess's law. All right, the next video, we'll do a few more. Okay?